Hey guys, thanks for tuning in again to your chemistry videos. Thanks for being accountable for doing the work for our class. Alright, we have two learning targets today. The first one is I can write very large numbers and very small numbers in scientific notation. And the second one is that I can use my calculator to do calculations with scientific notation. Scientific notation is just a shorthand method that we use in science to write very large or very small numbers. And it's probably not new to you. You've probably done this in math. But in chemistry we'll actually do some calculations with scientific notation because very often we're talking about very, very large numbers of particles or very, very small volumes or masses. So here's an example. This number is actually 4,500,000. But instead of writing all of those numbers out, we could simply express that as 4.5 times 10 to the 6th. A very small number would be this one, 0.000045. That's kind of a chunky number to have to deal with, so it's much easier when you're writing it and doing calculations to use the scientific notation, which would be 4.5 times 10 to the negative 6th. We're going to talk about these exponents a little bit and how we determine which is positive and which is negative. Just a couple of things to get you oriented to this type of notation. This part of the scientific notation, the 4.5 in this example, is called the mantissa. The mantissa. And then this part over here, the 10 to the 6th, is the power of 10. So I do want you to make sure you understand which part I'm referring to. The mantissa is the number here, usually a decimal number, and the power of 10, of course, is the number that has the exponent. Alright, so the mantissa is written with only one digit in front of the decimal point. So for instance, in this case here, this is just 2,500, so it's not really that big of a number, but we can still express it in scientific notation. This is 2.5 times 10 to the 3rd in scientific notation. And notice there's just one digit in front of the decimal point. Now sometimes you will have numbers after the decimal point, and that's okay, and it's actually important, and we'll get to that later. But it's always important that you only have one digit in front of the decimal point. Alright, so let's talk about how we write scientific notation with very large numbers. First of all, you must move the decimal point to the left until you reach the mantissa. Remember, which is a number with only one digit in front of the decimal point. The number of places that you move is going to be your power of 10. So let's look at some examples. Alright, so this very huge number, which actually if you Google it, there's two different ways to give it a name, but we can actually call this one 253,000 million. But who wants to deal with all those zeros? So we definitely would want to express a number like this in scientific notation. So in the purple ink, what I did was just show you how in a number like this whole number, of course your decimal point is always at the very end. And so I just showed in the purple ink we're moving over until we get to the mantissa, which remember is the number that only has one digit in front of the decimal point. And so in order to get there, that's 17 places. So it took 17 places to get to the mantissa. And so that becomes your exponent there. And so just a little review on these terms. The power of 10 here, so this 17, the power of 10 is called superscripted. It means it's written above the line. And we call that an exponent. Hopefully that word exponent is not new to you. But so this exponent here, that 17, that tells you the number of places it took to get to the mantissa. So let's do a little practice here. You may want to just write this down in your notebook as practice. So the question is convert 34,500 to scientific notation. So if you write out that number longhand there, think about what would you have to do to write it in scientific notation. Okay, take a couple seconds to think about that and then write down the answer. Alright, I'm going to reveal the answer here under the big pink square. Alright, there you go. So there's your answer. In order to reach the mantissa over here, we have to move the decimal point 1, 2, 3, 4 places. And then we use that 4 as our exponent in the power of 10. So the answer is 3.45 times 10 to the 4th. Now notice that I used all of the numbers that are included that are not zeros in the scientific notation, and that's really important that you do that. All right? Now let's look at very small numbers. To write a very small number in scientific notation, you must move the decimal point to the right until you reach the mantissa. Another thing to remember about very small numbers, specifically numbers less than 1, is that numbers less than 1 always have a negative exponent. And so, for example, in this example here, we have 0.00004. To get to the mantissa, which is going to be 4, and since there's no numbers after that 4, you would just write 4. It took 5 places. So we counted 1, 2, 3, 4, 5. And so we write 4 times 10. This should be a negative 5th. I didn't even write it in there. My mistake. But that should be a negative 5th because we went over 5 places. So let's do a practice here. Convert 0.00065 to scientific notation. So in this case, we write out in the longhand 0.00065. And remember, to write that in scientific notation, you have to move the decimal point until you reach the mantissa, which of course is the number that only has 1 digit in front of the decimal. Now don't make the mistake I did up here. Remember that this number is less than 1. All right, so let's look at the answer there. Kind of scraped it off, but the answer would be 6.5 times 10 to the negative 4th. We're going to do a lot more practice with scientific notation in class tomorrow. The other thing that we're going to talk about is how to do calculations on your calculator. Some calculators are different, and so you're going to need to take responsibility on learning how to do scientific notation with your calculator. And we will work on that in class tomorrow. All right, thanks a lot, guys. See you soon. Hi everybody, thanks for joining me again for your chemistry video. This one is on density. So let's look at our learning targets for this video. The first one is I can use the density triangle to solve problems, and the second one is I can explain